Hey, welcome back. Thanks for joining the channel. Good to see you again, and hope you're all well. Today on the bench I have an Orb Audio Super 8 200 watt powered subwoofer. This is a plate amplifier. This was part of a group of items that a client dropped off. He dropped off a couple plate amplifiers, and he dropped off some other stuff too. So we'll get to those in future videos, but let's tackle this one first. Orb Audio. Okay. He says the problem with this is it blows fuses. He couldn't figure out why. He has an idea, but let's look at this. This is a plate amp. I've never really worked on plate amps before. I don't know anything about them, so that's my disclaimer. Apparently all it is, it's just a power supply and amplifier, and its only intention in life is to just power a subwoofer. And yeah, it's pretty basic. So what does it do? It feeds power in here. We got a master power switch. We also have a power switch up here on auto and mute. I guess that's more of a soft power switch. Then we got some controls: volume, phase, crossover frequency. You can enable and disable a crossover. We got some inputs. We have a line input, and then we have high level inputs. If you want to pass through your speaker from your amplifier through to your speakers, you can pass it through here, it looks like. And yeah, it's kind of versatile. So we flip it over. We have our input power and input switch, our power switch. We have like what appears to be a switching power supply here on this part. And in this side here, this part of the board here, it looks like this is a Class D amplifier. That's what they're doing, I think. Got a bunch of output devices here, it looks like, and they are thermally coupled to the plate itself to dissipate some heat. There's a board here that looks like it's all op amps, so it's doing signal conditioning. And so from our inputs, it goes straight to this board, does all its signal conditioning with the pots and the switches and the op amps and the filter networks, and then it goes through to the power amplifier, which looks like again Class D. So he says it blows fuses. Let's have a look here. There's a fuse here on this board. It says F1, but it's jumpered with a 0 ohm short. You can see that right there. So that's not our fuse. The fuse is actually in the is this an IEC connector? Ungrounded. So you pull this fuse out, and there's a little 5mm fuse here. And yeah, the link is blown, so it is blown fuse. And this is a 2 amp, 250 volt. Okay, so it's a correct fuse according to this, and it's blown. So what do we do from here? We got a blown fuse on the input of a switch mode power supply. So what does that tell us? Does it tell us the amplifier is shot? No, I don't think so. Probably the fault lies in the input stages of this power supply, or the primary. So typically we got input power here, we got filtering, common mode choke, more filtering, and we have a thermistor here. This is probably to limit inrush current, and then we have a bridge rectifier, and then from there it goes to our filter caps and our Mosfet devices for switching onto the power supply. So that's basically switch mode power supply in a nutshell, and they're all basically the same. On the output of the device, looks like we have a couple of rectifiers way off on left field here. Main filter cap, which is 100 volts at 470 microfarad. Some smaller caps. And then aside from that, I don't know what they're doing here. So, before I turned the camera on, I tried looking for a schematic. I went on, did a Google search, not a Google search, I did a search, and came back with a few hits on other people looking for schematics as well. And one of them said that he even went to the manufacturer to ask for it, and they refused because of proprietary information. So yeah, there's that excuse. This there's nothing top secret about any of this. This is all common. This is probably ripped off from somebody else, to tell you the truth, because this thing looks like it's all been made in China. Yeah, exactly. Here it is, made in China. Super 8, 120 volts. And they didn't want to put the made in China thing on the back where all the information should be. It should be written here, made in China, but they didn't want to do that. They hid it in here. So I'm not bashing this amplifier or anything. I'm just saying this is reality we have to deal with. So let's I think the main step here is let's pull this board out so we can actually access the underside of it. We can start doing some troubleshooting and testing. And I don't think there's any point in putting another fuse in just to have it pop in front of us, because we know that's what the trouble is. So okay, let's start there. I'll take this board out. Alright, now that we got it out, we can have a better look at it, and we can see one of the first things you do when you're working on a switch mode power supply is have a look where the isolation barrier is. See this line here where there's nothing transferring from one side to the other, and that's on both sides of the board. That is your isolation break. So everything on the right hand side here is your primary, everything on the left hand side here is your secondary. So we're going to be focusing on the primary side today because we have a fuse blowing device here, and that typically is something wrong on the primary side. If we had a short circuit on the secondary in one of the rectifiers or a filter capacitor or an amplifier chip or something to that effect, typically the primary would still function, but it would shut itself down because it's in an overload. Hopefully we hope that's the way it works, but that's typically how it works, not always. So we have our input power here. We have our full fuse. It's marked on the board F1, but there's no fuse here. It's just a jumper wire because our fuse is located in the input connector for the power cord. And then we have some capacitors across the line cap. It's an X2 cap. Here's another cap here. No, this is not a cap. This is a MOV. I think this is an input protection device. Does it go across the line? Let's have a look. Let's see here. Yes, it does. It goes right across the line. So that is not a capacitor. That is a surge suppressor. And then we have a capacitor to ground. There's a ground screw here. And this capacitor would be a Y2 capacitor. This is probably a low value. And then we have a common mode choke. And a couple more capacitors across the line, I'm assuming. Looks like they're wired. No, hang on. That is for the capacitor to ground. I think these are in series with this capacitor. Okay, then we have an unusual device here. And this is what the owner commented to me about. He says this thing blew up, and he marked it with a pen. And if you look at it really carefully, you can't see it on the screen. Maybe if I zoom in. Let's see here. There it goes. It's going to focus now. You see that black mark on the side, and there's a crack, and there's molten metal coming out? That's where the smoke escaped. And that's not a capacitor either. That is a thermistor. And probably what they're using that for is to limit inrush current for this device. And then we have what looks like a little bleed resistor. Probably a bleed resistor to make sure that these caps don't hold a charge when the thing's shut off. And then we have our full wave bridge rectifier. AC is the pins in the middle are AC. And then we have our negative and positive on the outsides. And then from there we have some more resistors, a few more jumpers, and then it goes over to our filter capacitor bank. We have two 220 microfarad at 200 volts, so we have a total of 440 microfarad. These are probably wired in parallel. And let's see here. Yes, I believe they are. And then some more filter capacitors. And then we have a little board here with a transistor on it. I'm assuming this is the control PWM control for the Mosfets, and then we have two Mosfets. It looks like two Mosfets, I don't know, I can't really tell here. One's an IRF 730, which is definitely a MOSFET. The other one I can't read, it's in the shadows there. I can clean it off, it's got gunk on it. I can't read it. Oh, it's an IRF 730. They're both IRF 730s. There's a pair of them there. I really don't know why they needed a pair. Usually it's just a single transistor running into the transformer. And that's pretty much basically it. All of this little circuit here. So let's start with doing some checks. It says it's got a short circuit, blows fuses. Let's see what this says. We're in the megohm range. What's going on here? So we're a megohm. Let's see here. Common mode choke, let's check here. Should be the same, megohm range. Okay, and then it goes into this resistor. Let's check the current resistance on this. And this is showing about 12 ohms, okay. And it goes into our bridge rectifier. So from the negative, that diode is working. That diode is working. From the positive, that diode is working. And that diode is working. So it seems like the bridge rectifier survived the event, whatever it was. Next we have our Mosfets. And typically Mosfets are gate source drain, or gate drain source. I can't remember which one it is. So the first pin is usually your gate. So the other two would be on this side. Let's check this here. We got dead short on this one. And if they're both wired in parallel, I expect there'll be dead shorts on both of them. Okay, so it looks like we're going to have to pull those Mosfets out and see if I have replacements or substitute, and see if we can get this power supply working again. So next job, I have to pull out this heatsink. I have to desolder these 6 pins and pull this out because I can't get a screwdriver in here to take out those screws. Everything's got this goop on them too, this thread locker. So I think it's just better if I pull out the heatsink and then I can deal with them outside of the circuit board. And then I can also get in here and check this little circuit here. There's little transistors, some capacitors, resistors, diodes. I can make sure all that is good too, and there's nothing blowing on it. If we look at the back side, you can see some heat soaking around here. There's 2 components here, and these are actually, I was looking at this earlier. This is a plus 15 volt regulator and a minus 15 volt regulator. This is supplying all those op amps on the other board with power, plus minus 15 volts. And I expect that is fine. It looks like a little bit heat soaking there. There's one component here that doesn't look good. It's a resistor. It's on the secondary side as well. And that is a R52. I can't even tell what value it is because the colors are all cooked and they're all just gray and black now. But I'm assuming that resistor is going to be okay because I don't know what value it is. And that's about it. Okay, so I got the heatsink out with the 2 transistors. It wasn't easy. This is lead-free solder, and it's plated through holes, and it really fights you on the way out. So now that I pulled this board heatsink out with the 2 transistors, I can see more of what's going on here. If you can see this, I have one resistor that's cooked. Well, they're all cooked. Actually, 2 resistors cooked. We have, I didn't see the second one. 3 transistors on this side and one of them's cooked. 3 transistors on this side and one of them's cooked. And we have a couple of monolithic caps here. These look cooked too. They're obviously brown. So a lot of heat on this board. So I want to remove this board as well because I'm going to have to replace these parts. I don't know what value these resistors are. To tell you the truth, I have no idea. So I'm going to have to do some guessing here and maybe look at some other designs and see. And I want to remove this board, so I have to replace parts on this. And I also want to remove these two filter caps because they're suspect as well. Usually when a MOSFET goes, it's because the filter capacitor has already died, and the voltages supplied to the MOSFETs are not regulated, or they're getting too choppy, and the MOSFETs have a hard time dealing with that. So these filter caps have to come out, and I'll test those. This board has to come out, and let's have a look at this for right now. So let's do this on Diode Check. So across the drain and source, looks like we have a good diode there, and open that way. Between the gate and the drain source, it's open, it's fine. This one here, we got a dead short across the drain and source. So that's our short circuit right there, this transistor. They're both IRF 730s. I'll have to look at the specs sheet on that, current, voltage, to see. Pretty much any MOSFET will work in this application. It's just a matter of matching up the current dissipation, power dissipation, and voltages it works at. And this is nothing special. This is a low voltage switcher. It works at 200 volts or less, right? And I do believe these are wired in parallel, these two capacitors. Maybe they're not. Maybe it's... Anyways, I could power this up, and then I could tell what voltage across these caps right now because we removed our short. So maybe I'll do that, and I'll see what our primary mains voltage will be. Okay, so with my Widowmaker, I'm going to connect it up to the input terminals for the AC voltage, and I got it connected to my isolation transformer. So let's turn that on. And it's powered up right now. Let's check this, see what we get here. 164, 164, 164. Yeah, I think those two caps are in parallel with each other. There's no weird high voltage doubler here. That's 0 volts, and this is 0 volts. Okay, shut this off. Alright, so let's just discharge those caps. I don't want to get zapped. I'm going to pull those caps out, and let's see what voltage they're at. They should be dropping by now. Drop down to, okay, they're under 20 volts now. I can remove them. I'm not suspecting these to be anything wrong with these caps. Okay. And look at this. That's ground zero right there. This cap failed. And yeah, look at the carnage here. Wow. Okay, so we have a failed cap that caused a lot of other parts to go kaput too. And that is not even noticeable when it was in place. You couldn't see it with all this junk around here. All this crap has to come out. All this glue that they used. Look at that. That's amazing. I hope our traces are okay. Might have to reconstruct those. Okay, I'll clean this all up and then we'll see what we can do. I just want to check this other cap there that's remaining and see how bad it is. Okay. All right. So this one's actually reading 212 microfarads, which is good. And it's got a 285 milliohms ESR, which is also good. It should be better than half an ohm. So this capacitor is still good. This one failed, effectively cutting the capacitance of this in half, which contributed to probably a lot of other things happening. So we'll have to find a new pair of caps for this. Next, I'm going to remove this little printed circuit board here and see if I can troubleshoot. Well, I know what's wrong with it. There's a couple burnt resistors here. I don't know if they're intact or not. I'm going to take this out and we're going to rework this board first, and then we'll start putting everything back together. This board has to be removed, and I'm going to do something a little different. I got 8 pins here and it's all plated through holes, and the solder they use is lead-free stuff, and it's not very friendly. So what I did is I taped on some heat shield, some aluminum foil, just to protect the board. And what I'm going to do is I'm just going to secure this in a vise so I don't have to use my hands. I'm just going to use a butane torch, and we're going to heat these pins up and pull that board out. So let's just try this out. Just want to go easy on the heat. Heat it up slowly. It's getting loose already. There it goes. And I don't think I damaged any of the vias, so that's good. Success. Now I'll clean this all up. And hopefully I didn't scorch the board too bad. No, it looks pretty good. Just have to suck the solder out of the holes now. Also, looking at these two caps here is kind of they could be damaged as well. If the electrolyte leaked underneath, it looks like there's something going on here under these caps, so I might end up replacing these as well. this aside and have a look at this. And you can see those two burnt resistors. Transistor here, I don't know what this is. This could be something. What is that? MPS A92. Okay, that's a common resistor. Check these resistors, see if they're burned out actually, if they're just cooked. There's a chance there might be nothing wrong with this board. It's just a matter of okay, what do we got here? Let's try to start on this end. This one looks like it is 33 ohms. I'm not sure though. $546. $546. $390. $546. $46. This one's going to be $390 as well. $106 ohms. 106K? Is that what it said? 106K. 106K. $200K. I can't read any of these colors. They're all, that's 100, no, it's 1K. Like I said, I can't read any of these colors. They're all just like black lines and brown lines. If they were colors, they're not anymore. I'm going to have to examine this circuit and see what's going on with these resistors. These might have been cooked, but they could still be intact. I might have to remove those and see if they measure anything. Let's try some of these diodes. That's good. This one looks like a Zener. Okay. I don't know what this part is here. It's not, it's got two bands, one on each side, so it could be something. I don't know. Everything's good. Transistor. I think that transistor is okay. This board might be alright. I'm going to have to look at the circuit on this and decode what these resistors do. Alright, this just keeps getting better and better. The more I look into this, the more damage I see. So I pulled these capacitors out. This one looks fine. This one doesn't look so fine. Look what was going on underneath it. It was carbon tracking, and let's clean this up and have a good look. Yeah, it's not very good at all. So what's under here? Looks like, get out of the way. Looks like it was arcing. Wow. Yeah, it was arcing underneath there, but what does it connect to? It goes through this via here, and that goes to that on the subboard. So we might have to reconstruct some stuff here. This is, yeah, this is terrible. I don't expect this capacitor is any good anymore. I'm not going to try using it. It's 104, 100 nanofarad, 250 volt. Let's, just for the hell of it, let's test it. Actually, it's still good. It's 103 nanofarads, and it's got a 15 ohm ESR. It's not bad. It still survived, but the board didn't. I don't know what I'm going to do with this. I'm going to have to reconstruct some of these traces, and oh man, look at that. Just arced into everything. I'm going to have to clean that all out, and get rid of all that carbon, because we don't want it lighting up again, and we'll have to do something. On a positive note, I do think I found a replacement MOSFET. This is our MOSFET that was in circuit. It's an N channel, 400 volt, 750 milliohms, and 5.5 amp power mesh MOSFET. And this is what I found in my parts bin to replace it with. It's Infineon. It's an SPP 20N60C3. This is a 650 volt, 20 amp device. It's got 190 milliohms RDS on. So it should drop in and work. The same pinout. So this should be okay. It should work. We'll go with that for our MOSFETs. Get a couple of new electrolytics. I'm going to clean up this board. I need a couple of these capacitors, 100 nanofarad, 250 volt. Now this thing, I still have to figure out what happened here. Capacitor leaked, electrolyte all over the board, and it dripped over onto these capacitors here that were holding back 160 some volts. Started carbon arcing and burning out, and it destroyed a lot of traces. This trace here, for example, comes from a transformer winding, and it goes up to this via. The underside of this via goes onto our subboard. Here is the ground for the capacitor. It's connected to ground by this here. This side is connected to our high voltage 165 volts from the filter cap. So there was 165 volts directly across this cap, and that's what the carbon arcing is all about. The electrolyte leaked on it, it started conducting, and it started arcing. You can't see that there. So there's our failure, and that took out everything else. Took out one of the MOSFETs, and hopefully that's just it. So let's start piecing this back together. Okay, just to show you a bit of what's going on here, I had to take the Dremel and clean out all the carbon around here. This is all burnt through to the fiberglass, and it was carbon arcing. And there was a spot here where it was carbon arcing too, so I took the Dremel and cleaned that out. So we should be good there and here. This one trace was destroyed, so I had to run a wire from the transformer lead. And this is just a single strand wire, and it goes to this via to reconnect that trace. And now I can put in this capacitor. The capacitor tested fine, but I'm not going to chance it. It's got carbon on the bottom. I'm just going to replace it. And everything else can go back in now. I got my transistors mounted, and I have this board. I did a few things to this board. I replaced these two 390 ohm resistors, even though they were still good and still showing the right value, I assume. And I lifted the legs of a couple of these capacitors, and I tested them as well, and they're fine. Can't find anything really else wrong with this board. It has been cooked something severe, because every time I tried working on this board with the soldering iron, the pads would just fall off the board and the vias would pull out. So I had to be very careful on what I did with this, and I had to make sure when I put it all back together, I had to continuity check all these parts were connected. So this is ready to go back in. It goes in there, and then I'll have to hunt up a couple new filter capacitors, and then once we reassemble everything, we should be able to test. So I think we're good to go. Okay, we're all back together. Let's do a test. Either we're going to get a smoke show or we're going to get success here. So which do you think it's going to be? I got bets on success. So this is to my isolation transformer. Got everything put back together and soldered in. Two 330 microfarad at 250 volt caps. They're more than adequate. I got positive lead of the voltmeter connected across this big cap. This is a 470 at 100 volts. So if this supply starts up, this cap should charge, and we should see a voltage on here. So here we go. I'm going to press the button. And it came up, and we got no smoke. What do we got for voltage here? It seems like it's low. Maybe it needs to have something kick it on. That's funny, I don't see any optical feedback on this. So I gotta assume that this is working. Let's try that again. Let's try it with a different connection. We might have more problems than what we're led to believe here. So let's try it here. Turn this up to 100 again. Turn the power on. And it's not showing us anything exciting. It is working. Okay. You know what I'm going to do at this point? I'm going to shut this off. I want to test some of these other capacitors. I want to pull this one out especially and test this one. This is the main one on the secondary, and then some of these other little ones. And then if they all test fine, that's good. If they don't, I'll replace them. What I want to do is connect this back in with the rest of the circuitry, and maybe there's something that's going to kick it alive. So we'll do that. Okay, so I pulled this cap out. This is the main filter cap, I'm assuming, because it's the biggest one. On the secondary side, 100 volt, 470 microfarad. And this is a XC brand, don't know who, 85 degrees Celsius. Let's try this one out. And it comes back at 400 microfarad, and it's got 167 milliohms ESR, which ain't too bad. It's kind of weak from 470 down to 400. I might consider replacing that, but let's check some of these other ones here. My tester. Zero this out. Okay, this is a 470 at 50 volts. $16. Well, that's not good. This one's 100 microfarad at 25 volts. Should be 320 milliohms. 17. That's not good either. What else we got here? Another 470 at 50. 17. Seems to be a common theme here. 100 at 25. Again, 17. What the hell? They all wired together. 470 or 47 at 50 volts. This one I get no reading, so it's over 100 ohms. Oh boy. Okay, 100 microfarad at 25 volts. No reading. It's over 100 ohms. So all these caps are bad. And these ones have no polarity. These are 4.7s at 35. And if these are bad, yes they are, I don't have replacements for these. I don't stock non-polarity capacitors. We can make some up, but look at the brand name on this. Junzel. Junzel or Junk? Okay, well, I'll replace all these, and then we'll see how it performs after that. Alright, new caps are in. We're all back together. I put the old cap back in because I did not have any replacements, and this one didn't test that bad actually. So it's got a bit more life left into it. Oh, I forgot to put that one screw back. I checked these caps. They're getting weak, but they're away from the heat, so they're okay. They're standing, they're holding out, so I'm not going to touch them. So the next thing is to apply power. Got it all hooked up. Get the fuse in. Let's see if we have any power here. So plug this in. Turn on my isolation transformer and power it up. We got a light on the LED, a green light. So is it working? Got a green light LED here, and red when it's in standby mute. Okay, well, let's hook up a speaker and some source. Okay, here we go. Got a signal source, 400 hertz. Connected to a speaker. Let's turn the power back on and turn this on. Let's turn up the volume. Let's turn down the frequency. It's working. Okay, let's get a load on this and see what it's capable of. It's mute. It's working. Red light, back to green light. Okay, let's do a power test. Okay, I got it connected to a load, 16 ohm load. I'm going to try our 16 ohms because I don't know what this thing is capable of pushing. So we'll start with 16 ohms. Got it wired in for a voltmeter and my scope. You should be able to see it on screen. Let's turn this back on. I'm running through a isolation transformer, so you got to remember that we might not get full power out of this thing. Now, right now I got it at 100 hertz, and I have this turned full volume right here. I'm going to control the volume with my signal generator. I'm going to turn that up and down, and here we go. There's clipping there. Okay. So we're at 16.03 volts into 16 ohms. It's doing pretty good actually. Let's let this go for a while. Now we can turn down the frequency. It's at 200 hertz right now. Let's turn it to something lower. I want it to go into clipping right away. It favors the low frequencies. Yeah, I gotta turn it down quite a bit. Okay. Down to 90 hertz, 80, 70, 60. I smell smoke. Where is it smoking from? Let's turn it back on. Yeah, there's some resistors getting hot here. Let's try it at a lower volume. What I'm going to do is I'll get the thermal camera and we'll see what's going on with this thing. Seems to be performing good. I think it's just not built to deliver full power for any amount of time. That's what I'm thinking is wrong here. So let's get the thermal camera, see what's... I'm pretty sure it's these two resistors are getting hot, and probably the first time they got hot in a long time. Okay, let's try this again. There's a lot of heat coming from these two voltage regulators. Let's try turning it on. And we'll see where the heat is. I wonder if I turn it this way. Yeah, it's definitely those two resistors. You can see it here, they're hitting about 120 degrees C. See if I can get a picture of this. And I can show you. Okay, shut this off. It's hitting 150 degrees. Don't like that. It's right next to the capacitor too. Like I said, it's not meant for doing continuous duty. How much are we putting out right now? 11.43 volts RMS. Okay, I think we're done. Well, that's it for this one. What I did is I anchored a lot of these parts with some silicone just so that once it sets up, it's solid and it's not gonna things move around. You get a lot of vibration on this. It's a subwoofer, and I want to make sure these parts don't start breaking legs off and doing weird stuff. So anchor down as much as you can with some silicone. Yeah, that's it. It's working. Quite a few parts went into it. Let's see here. We got a pair of capacitors, mains, filters, fuse, a couple resistors. I changed these resistors. They didn't need changing, but I did anyway. This capacitor as well. It's pretty much cooked on the bottom. All these electrolytics and these two Mosfets. So quite a bit of parts going in for this little thing. And it's just failure from, well, low quality capacitors is one thing. That's probably the main thing that failed on this. This capacitor failed, and then it started a chain reaction which took out the Mosfets and made it an expensive repair. So, alright, we're done with this one. Thanks for watching, and we'll see you on the next one. Take care.